Now let's go through example 3, which is the last example of our formula. This example shows us the application of our formula in some word problems. The diagram below shows a rectangle ABCD inside a semicircle with center O and radius 5 cm, such the angle BOA and angle COD are both theta degrees. So in part A, we are supposed to show that the parameter P of rectangle ABCD is given by the expression P equals to 20 cos B plus 10 sin theta. So what we do is we try to find right angle triangles in the given rectangle. So we found that OCD is a right angle triangle with one known angle theta and one known length 5 cm. So with this, we are able to apply Torcaso to right angle triangle OCD. So for part A, for triangle OCD, sin theta will be equals to CD over 5. Multiplying both sides by 5, you will obtain CD as 5 sin theta cm. Similarly, if we find cosine theta, will be equals to OD divided by 5. Multiplying by 5 on both sides, we will be able to obtain OD as 5 cos theta cm. So now, if we are to find the parameter of the rectangle ABCD, will be equals to 5 sin theta times 2 plus 5 cos theta times 4. 1, 2, 3, 4. And hence, you get the P expression as 20 cos theta plus 10 sin theta. And that will be proven. Let's continue with part B. In part B, we are supposed to express P as a single trigonometric function. So, the single trigonometric function will tell us that we need to apply our formula. So, we take P equals to find the value of R, I'll have to take 20 square plus 10 square and the whole thing square root. Since the first term is cosine, I'll then use the cosine function. Open bracket, the same angle theta, and then since we are using the cosine function, we have to change the given plus sign to minus. Tangent inverse, second number 10 divided by the first number 20. Close bracket. And so this will be equals to root 500 cosine, open bracket, theta minus 26.57 degree, close bracket. We always give the working as 2 decimal place if the angle is in degrees. So this will be equals to 10 root 5 cosine, open bracket, theta minus 26.6 degree, close bracket, if they want the answer, because the answer for angles should be rounded to 1 decimal place. And take note, I have simplified the third here by splitting 500 into 100 times 5. So I've answered the first part of the question. Now let us answer the second part, and hence find the value of theta when p equals 16. So I proceed to let p equals to 16, which implies that this expression, which is p, will be equals to 16. If you take note, I've used the 2 decimal place angle for working. Now I divide both sides by 10 root 5. So I get cos theta minus 26.57 degree equals to 16 over 10 root 5. Now I substitute the compound angle as y. So I'll get the equation as cos y equals to 8 over 5 root 5. Once I divide both numerator and denominator by 2. Since this is our trigo equation, we'll do our trigo here. First step, find basic angle. Second step, find quadrant. So the basic angle will be equals to cosine inverse 8 over 8 root 5, giving me a value of 44.31 degrees. Notice the working is 2 decimal place. After that, I try to generate the range for y. From this diagram, I know that theta shouldn't be more than 90 degrees. So theta will range from 0 degrees to 90 degrees. Subtracting 26.57 degrees throughout, I'll get theta minus 26.57 degrees will range from minus 26.57 degrees to 63.43 degrees. And so I proceed to get the value of y, which is supposed to be either in the first or fourth quadrant. But in this case, the fourth quadrant will be outside this range. So I'll just take the answer from the first quadrant. Then I substitute y as theta minus 26.57 degree. So from here, I just add 26.57 degree throughout, and there I go, that I obtain the value of theta as 70.9 degrees, with the final answer rounded to 1 decimal place. So from here, I've completed part B. Now let's carry on to the next slide to solve part C. In part C, we are asked to find the value of k if the area of the rectangle is expressed in this form: k sine 2 theta cm square. So I proceed to find the area of rectangle ABCD, taking the area as length times breadth. So to compute the length AD, I'll need to take 5 cos theta times 2, and times, to compute the breadth, I'll have to just take the value of CD as 5 sin theta, which we have worked out earlier in part A. Now multiplying the constants, 5 times 2 times 5, I obtain 50 sine theta cos theta. Now since they want my answer to be in a double angle form, I will do my chair. Sine A cos A, half sine 2A. So half times 50 will yield 25 sine 2 theta. After comparing the answers, I find that the value of K is 25. So we have completed the example on the application of R formula in word problems. I hope you have enjoyed yourself.